Hello guys, welcome again to the tutorial session for quiz acid and base. So like the previous quiz, we have altogether 5 questions and I'm going to go through it one by one starting from question number 1. So let's get started. So question number 1, Lulu carefully pipettes 25 ml of 0.525 molar of sodium hydroxide into a test tube. She placed the test tube into a smaller beaker to keep it from spilling, then pipettes 75 ml of 0.355 molar HCl into another test tube. When Lulu reaches to put this test tube of acid into the beaker along with the test tube of base, she accidentally knocks the test tube together hard enough to break them. The respective content combined at the bottom of the beaker determine the pH of the resulting solution. So this is quite a lengthy question, but I'm going to go through it one by one. So when you have this kind of question, the first thing that you need to know is that you need to look at what is your reactant, because here you have 2 different reactants, which is sodium hydroxide and also hydrochloric acid, so NaOH and HCl. You don't have to look at the value first, just look at the reactant and try to make your own chemical equation, a balanced one. So basically you have NaOH plus HCl. So and then what is the product? So usually you have base and acid, means that is a neutralization process. So basically you're going to create water, so H2O. So and then you have Na, so this one shall be like Na plus OH minus, and this one shall be like H plus and Cl minus, right? So since you already remove the H2O, so you remove the H plus and the OH here, so you only have this Na plus, and then you have Cl minus, so you will get the other product will be NaCl. Alright, next you need to check whether this equation is balanced or not. You have one Na, you have one Na here, one Cl over here, so you have H and H, 2 H's and 1 O, so this equation is balanced. Right, next, when you look at here, there's things that you need to calculate, which is the what is the number of mole, because when you have this equation you don't really need the molarity or the concentration of the substance yet, but you do need the number of mole so that you can do the ratio between these reactants, so that you know what is the product or the pH of the product, right? So given in the question, it states that for the sodium hydroxide you will have 0.525 molar of NaOH with the volume of 25 ml. So you need to use molarity is equivalent to mole over liter. So given in the question, the molarity is 0.525, so 0.525 is equivalent to the number of mole is what we are going to calculate, and this 25 ml you need to convert to liter, so 25 divided by 1000, so you should get the number of mole is equivalent to 0.525 times 0.025, because you have to bring 1, 2, 3, so 0.025, so it's equivalent to 0.0131 mole of sodium hydroxide. Alright. Next thing, the other solution is the HCl. So same drill, you need to use the molarity given here and the volume to calculate the number of moles. So I'm going to remove this. Right, so molarity of HCl equivalent to mole over liter. So the molarity of the HCl is 0.355, 0.355 equivalent to mole over liter, where state in the question the volume is 75 ml, so you need to divide by 1000. Therefore, the answer for your mole is equivalent to 0.355 times 0.075, right? So you should get 0.0267 mole. Right, this one is for HCl. So when you look at this equation, your balance equation here, from here you know that 1 mole of NaOH will react with 1 mole of HCl. Right, so from here, if you have 0.0131 mole of NaOH, definitely you will have the same 0.0131 mole of HCl. Okay, if you look at this value and compare it to this value, so you can see that you have more HCl, more than what you need if you were to react it with 0.0131 mole of sodium hydroxide. So from there we can say that this NaOH is the limiting reagent. Right. So in terms of you getting how much product is dependent on your limiting reagent. So same goes, for example, here means that not every single thing in here is being reacted because HCl have excess. HCl, right? Now you need to understand how much HCl is excessive. So at first you have 0.0267 mole, and then you only use 0.0131 mole. So what is the balance? Is 0.0136 mole of HCl. Right, so this is the number of mole of HCl in excess. Alright, I'm just going to recap. Just now we have excess HCl, whereby the excessive HCl is 0.0136 mole of excess HCl. Right. Then the total amount of solution. Okay, what is the total amount of solution? See, you have 25 ml plus 75 ml. So 25 plus 75 is equivalent to what? 5 is 10. So 7 plus 2. So it's going to be 100 ml. This 100 ml, you need to convert it to liter. So 100 divided by 1000 becomes 0.1 liter. This is the total volume. Okay, so since you know that the HCl is excessive and HCl is a strong acid, right? So when the strong acid, the molarity of the acid is equivalent to the concentration of the H+. So we need to know now what is the molarity. So molarity is equivalent to mole over liter. So molarity of what? Molarity of HCl. So the number of mole is in accordance to the number of mole of HCl that is excessive. So 0.0136. This is excess number of mole for HCl. So the total volume of this, the whole thing, when the mixture have been formed, which is from sodium hydroxide and HCl, so the total volume is 0.1 liter. So you should get molarity is equivalent to 0.136 molar of HCl. Okay, but if you check back on your question, determine the pH of the resulting solution. So pH, since that this is a strong acid, right? So the concentration of HCl should be equivalent to the concentration of H+. So when you want to calculate pH, so pH is equivalent to negative log H+. So you already know what is the concentration of H+, this one, right? So negative log 0.136. So you should get your pH is equivalent to 0.8665. So this is your pH, your final answer.